Hey y'all, I want to start class today with a challenge, and it is not a math challenge, it is a kindness challenge. I want to challenge you to go up to your mom or your dad or whoever you're living with right now and ask them what their least favorite chore is. And then I want you to do that chore for them and see the way that their face lights up and it makes their day brighter. See, this is really difficult for everybody, the staying home, the social isolation thing, but it is especially difficult for their parent because they have to balance having work and making sure that you're doing your schoolwork and making sure that the house is taken care of and the family is taken care of and everybody is healthy. And it would mean the world to them for you to go up to them and ask them their most difficult chore and do that chore for them and just watch how their day improves. And it makes you feel good to do nice deeds as well, which I think is also going to make you feel a lot better about being stuck inside. Because I don't know about you, but I'm starting to go a little bit crazy. So today we're going to go over the 4 most highly missed questions on the quizzes from last class, our Unit 7B study guide. The population of Brandon, Florida can be modeled with the function f of x equals 12,000 times 1.08 to the t power, where t is time. What is the average rate of change from year 0 to year 2? From year 0 to year 5. So average rate of change is just another way of saying slope, but since this is an exponential function, our slope is constantly changing. Just like when we did successive differences, right? When you had a table like this, the number between 1 year and 2 years is different than the number between 2 years and 3 years. And I'm going to show you what that means up here. So, here's my function, 12,000 times 1.08 to the t power. So I'm going to write that up here. F of x is 12,000 times 1.08 to the t power. This was question 14 and this was question 15, but I'm going to talk about them at the same time because they actually go together. So, the first thing I need to do is find year 0. In year 0, what was the population of Brandon? So I'll plug in a 0 for time. So I'm just going to make a chart. These are my x values, these are my y values, and I'm going to look for an x value of 0. I'm going to look for an x value of 2, and I also know I'm going to look for the x value of 5 to find the y values. So first I'll plug in a 0, 12,000 times 1.08 to the 0 power. Well, anything raised to the 0 power is 1, so 12,000 times 1 is just 12,000. So the year when Brandon was founded, there were 12,000 people living in it. 12,000. I don't know if these numbers are actually accurate. I just use Brandon to make it interesting because I live here. So now we'll plug in year 2. 12,000 times 1.08 squared is like 1.08 times 1.08, which is 13,999 people. You actually got a decimal, but I'm going to round up because you can't have a fraction of a person. And after 5 years, 12,000 times 1.08 to the t power. This t should be to the 5th power. So 17,623 people. So 5 years after Brandon was founded, there were 17,623 people. So what I'm looking for is the average rate of change, which is like the slope. So here's what I'm going to do. Slope is this formula. y2 minus y1 over x2 minus x1. And I know that this might not be something you were thinking about because this is an exponential equation and this is the slope of a line. What this problem is trying to show you is that the slope is getting higher and higher on an exponential function. So from year 0 to year 2, our y2 is 13,999 minus our year 1 is 12,000 over our x2 is 2 minus our x1 is 0. And if you were to solve out the top, solve out the bottom, divide them together, you would get 999 people per year, because again, you can't have a fraction of a person. So the average rate of change between these 2 years is 999 people per year moved to Brandon. And now we're going to do the same thing to find the average rate of change from year 0 to year 5. y2 minus y1 over x2 minus x1. Our y2 value is 17,623 minus our y1 value is 12,000. And I'm using 12,000 because the question is asking me from year 0 to year 5. If the question asked from year 2 to year 5, I would be using the number with the 2. But it's not, it's asking me from year 0, so I'm using the y value with year 0. Over our x2 is 5 minus our x1 is 0. So I'm going to subtract the tops, subtract the bottoms, divide the top by the bottom, and I end up with 1,126 people per year. So from year 0 to year 5, on average, 1,126 people moved to Brandon per year. And the average number of people per year can be different. This goes along with the concept that the average is you take everything that you have, you add it all up, and then you divide it by however many things you put in. On average, between year 0 and year 2, 999 people per year moved there. On average, between year 0 and year 5, 1,126 people moved there. And that's because more people moved to Brandon between years 4 and 5 than they did between years 0 and 1. So that was this question. After tennis practice, Cameron places tennis balls in canisters. She can use up to 8 canisters, and she places exactly 4 balls in each canister. The number of tennis balls is a function of the number of canisters. So the important part of this sentence, or this paragraph, is this last sentence here. The number of tennis balls is a function of the number of canisters. You know how when you write a function, you say f of x equals blah, 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 blah. I'll say like 3x. And then whatever you say, function of whatever this x value is, you plug it into the x values. So this f of x, it is your y values. This is your y values that go along with your x values. So the number of tennis balls is a function of. So f of x is the number of tennis balls. Because it is a function of the number of canisters. So you plug the number of canisters in, and you get out how many tennis balls there are. So x values are your canisters. Well, I know that my y values happen to be my range, and my x values are going to be my domain. And so I know that she can use up to 8 canisters. So the number of canisters is whole numbers up to 8, because you can't have a portion of a canister. So whole numbers from 0 to 8, right? And so my range, I know that she places exactly 4 balls in each canister. So if I had 1 canister, I'd have 4 balls. If I had 2 canisters, I'd have 8 balls. If I had 3 canisters, I'd have 12 balls, and so on and so forth. So these y values are your multiples of 4. So if we take a look at our option choices, my correct answer is that the domain is whole numbers between 0 and 8. And that's because our x values are our canisters, which is the domain, and I said whole numbers 0 to 8. And the range is all multiples of 4 from 0 to 32. I didn't get that specific up here, but I did say that it had to be multiples of 4 because you put 4 balls in each canister. David needs to paint 5 rooms of the same size. Each room takes him 6 hours to paint. The number of minutes it takes is a function of how many rooms he paints. Select the domain of this function. So again, we're talking about domain and range, or what is a function of what. So f of x and x. So x is what you would plug into the function, and f of x is what you get out of the function. So if it takes him 6 hours to paint a room, we're plugging in how many rooms he paints, right? If he paints 1 room, it takes 6 hours. If he paints 2 rooms, it takes 12 hours. If he paints 3 rooms, it takes 18 hours, and so on. So our x values is the number of rooms, which means that f of x is the number of minutes it takes. Minutes it takes. Now f of x is our y values, that's our range. And x is our x values, obviously, that's our domain. Now David is not going to paint a fraction of a room. He's going to only paint whole rooms, so we're using whole numbers. David might not paint any rooms, right? I mean, I don't need any rooms in my house painted, so David's not going to come paint in my house. So my domain is he could paint 0 rooms, he could paint 1 room, he could paint 2 rooms, 3 rooms, 4 rooms, or 5 rooms. Because in this situation, David needs to paint 5 rooms. So our domain is 0 through 5.